This is Unit 5C. It deals with projectile trajectory. So quite a lot going on here, even though there's relatively little material. The key thing is to understand Newton's first two laws. If we have balanced forces, we have no acceleration. And if we have unbalanced forces, we do have acceleration. And normally we consider those separately, but here we consider the two combined in 2 dimensions. So we have some kind of projectile, a cannonball being fired off a cliff here. It's a square one in this case. Now the horizontal component, the horizontal part of the motion, is an example of Newton's first law. The forces are balanced, so there's no acceleration. There is a tiny bit of air resistance, but a question always tells you to ignore that. There is no force driving this forward. It's a common misconception that you need force to sustain motion. You don't. You need force to change motion. So in essence, we have smooth, steady motion in this orientation, the horizontal orientation, H there. Now in the vertical orientation, we have something quite different. We have a Newton 2 situation. So Newton's second law tells us what happens when there is an unbalanced force. And the answer is we get acceleration. So the force in this case is the gravitational force downwards. Again, arguably you could say there's a bit of air resistance, but it's so small that we ignore it. Now we combine those two and we get this curve. And we can see that more clearly over here. We have this parabolic curve until the object hits the ground. Now the faster we fire it, the smoother or the more drawn out that curve will be. It actually makes absolutely no difference to the downward motion. Gravitational force never has a brake. It doesn't really care what the horizontal component is doing. It'll bring these two to the ground at exactly the same moment. However, if we fire it fast enough, and we're talking here about 8 kilometers per second, this curvature can actually match the curvature of the Earth, and we get orbit. Now you can call this falling if you like, if it appeals to you. Falling and the Earth's curvature is constantly falling away from you. However you describe it, you get the same result. So we have a balance between the object's natural tendency to want to carry on a straight line, and we have gravitational force pulling it away from that line, and if the speed is just right, we get this curved path, and we call that an orbit. So down here at the bottom we have the idea of velocity made up of distance per time and also direction, and if we have time again we get acceleration. The force, as we said, was gravitational, and in terms of direction we have to think about the vertical direction and the horizontal direction.